but honestly, this has solved every single one of my IEnumerable issues as of late. In this video, I'm going to be talking about designing APIs that use either IEnumerables or collections, and we're going to look at this from the perspective of both parameters and return types as well. In a previous video, which I'll link right up here and you can check that out and then come right back, I was talking about the usage of enumerables and how that solved a problem for me in the past, but then it unfortunately led to more problems with the teams that I was working with and how people were using enumerables. In particular, this had to do with iterators and the fact that they are lazily evaluated. I'm going to be diving into how I choose whether or not to use enumerables, read-only lists, or read-only collections in the APIs that I'm designing. Before we get into it, just a quick reminder to check that pinned comment for a link to my free weekly software engineering newsletter. Alright, so the content of this video is looking at API design, and in particular we are going to be looking at enumerables, iterators, and collections. So we're not focused on interfaces and object-oriented programming, classes, and all that kind of stuff for this conversation, although some of the concepts in terms of how I'm evaluating the weight of the decisions I'm making are probably going to be applicable, so you might be able to transfer them to other things. When we go through these decisions, we want to take the perspective of the caller to try and weigh the pros and the cons. So we want to think about how to make it easy for the caller, right? So we want to make sure that we can get them to provide information to us easily through our API, but we also want to make it very obvious about what the API is going to be doing. Now, what we have to balance this out with is the perspective of the person implementing the API. And often this is going to be us for these conversations. So in terms of what data we're taking in, are we able to do everything that we need to do with that data coming in effectively? I mean, the minimum bar that we want to set for ourselves is that we have enough data, but doing it effectively is also important. Otherwise, we might want to consider redesigning the API in the first place so that we can do a good job for ourselves. Now I'm going to jump over to Visual Studio, but I just want to remind you before we start looking at code that these are just some of my opinions and how I've arrived at them over years of working in C#. My intention here is not to tell you that there's only one right way and there's wrong ways and none of that. This is all just my opinion, my experiences, and I want you to take away from this video the different ways that I'm trying to analyze and come up with pros and cons, and that way that you can make your own decisions. I'm not here to tell you that my way is right. I want you to learn how you can do this analysis and make informed decisions for yourself. After all, if I tried to make up any rules for the things that I'm about to tell you, I am sure that you're going to find exceptions to those rules, and I would agree with you. There's always going to be situations where the rules are broken. Let's check out some code. Alright, I'm going to try out this split screen approach so that you can see me talking with my hands as I'm trying to explain the different parts of these APIs, because there's not going to be a lot of code that we're looking at, but there's going to be a lot of explanation about that code. The first type of thing that we're going to look at is passing in collections or enumerables as parameters into methods, and afterwards we're going to look at returning enumerables or collections. So the first part, parameters. When I think about historically how I've liked to approach this, again, if we're looking at the parameter being passed in, I like to be able to say, okay, look, if I only need to iterate over things, just give me an enumerable, right? And if I need to iterate over things, but I also need a count associated with that, then I probably want something like an read-only collection. And then there's going to be situations where I need a little bit more, where enumerating and having a count isn't enough, but some algorithms that I write where having access to a particular index within a collection is going to be valuable. And in that case, I want an read-only collection. So those three types of things are usually what I'm looking at. And I mean, we could talk about dictionaries as well, but I'm going to park that for another conversation. This is mostly just about collections of items. Now, you might have noticed that I mentioned enumerables and two read-only variants, and it's not very often that I write methods that are something like populate X, where I'm passing in a mutable collection, and that way my method is responsible for populating something and either adding things, or it could even be removing things from a collection. I generally don't write methods like that. It's not that they're wrong, but I often find that I would much rather feed the data back out of the method versus operating on something inside of it. That's my personal preference, so what we're going to be looking at here are read-only variants of things and enumerables as well. Now, you might have noticed on the screen that I've left some comments in this method, and these are going to be some of the goals that I want to talk about for when we're focused on passing parameters into the method. The first one is kind of what I just talked about, where we're preventing mutation, right? So we want to be able to use read-only variations of things instead of just a straight-up list or a straight-up array. And that way we are signaling to the caller that we don't want to go modify anything, and in fact we're enforcing that by having read-only variants of it. Yes, you could do something a little bit weird like casting these things inside and trying to get back a mutable collection, but if we ignore that because that's a little bit weird, we should be signaling to the caller of the API that we're just trying to do good things. I also mentioned here that we want to make it easy for the caller to give us that data, right? So if we think about collection implementations in C#, essentially everything implements an IEnumerable. So that would be the easiest thing for a caller to be able to give us. They could just give us an array, a list, a queue, a stack, you name it. If it's a collection in C#, it's going to be implementing IEnumerable. And that way, IEnumerable as the base type that we take in, so this parameter right here as IEnumerable, would be the easiest thing for a caller to provide us. So IEnumerable is also read-only, just like the iRead-only list and iRead-only collection, so that's cool, but it doesn't have a count and it doesn't allow us to index either. But there's also a couple of other drawbacks to using an IEnumerable as the parameter that we're taking in. And I did mention that it's the easiest one for a caller to be able to give us, that's totally true, but these 2 points here I think are really important, and they've bitten me in the past. And that's why I've tried to make changes to how I am creating a lot of my APIs, and I want to touch on these. So the first part is that we don't want to materialize a ton of data. If we are working in a system and we take in an IEnumerable, if at some point we need to be able to take a snapshot of that enumerable, be able to take out elements from that and effectively materialize that into something that we're holding in memory, we need to be very careful about that. If there's no constraints, and it's kind of difficult to enforce constraints at compile time about an enumerable being passed in, if we ever said like toArray or toList on that enumerable, we could run into a lot of problems if that iterator, if that enumerable was backed by an iterator, and that ended up materializing something from a database and had tons and tons of records. And the other thing that is really common that we want to avoid is that if we're working with a set of data, and let's say that we did only want to iterate over it, and we could use an enumerable, what we don't want to do is iterate over it multiple times if we are dealing with an iterator. And that's because if it's just an enumerable and it's backed by an iterator, that would mean that if it's going out to a database to do a query, it would effectively go do that query multiple times for every different block of enumeration that you need to do. And I want to show you this really quickly with a little bit of an example here. So I did include these 2 for each loops here, right? So if we have a for each loop over items and we're doing stuff inside of it, if we have another loop that's doing a for each over that enumerable, if that was an enumerable that was backed by an array or a list, it's not really a big deal. But if it's something that is an iterator and it's backed by something that's going to a database or doing other types of long-running operations, this will in fact go do that long-running operation multiple times. And then you might be going, well, hey, we can just avoid that by materializing it. And you're right, but going back to the previous point, if we just were to materialize the stuff ahead of time, so we materialize it before running these, if we don't know the source of that data, it might not be safe for us in the context of this method to be able to materialize it. So I think if you wanted to do something like that, you would probably need to indicate to the caller that that's going to happen. But I just think that there's a better way to do that. And I think that the better way to do that is just to give control back to the caller to materialize their enumerable when they need to. That way, as the implementers of this method, we don't have to guess at all. So what I wanted to point out is that many times now, instead of using an IEnumerable here, I will probably just stick to an iRead-only collection if I don't need to index into anything, or an iRead-only list if I really need to operate on particular indices. A lot of the time, I do avoid using an IEnumerable even as the input, unless I just plan on doing a simple filtering implementation over a set of data, and I don't have any plans to do any materialization inside of it. So for me, I still do use all 3, IEnumerable, iRead-only collection, and iRead-only list. However, IEnumerable is starting to take more and more of a back seat because I am trying to enforce my caller to do the materialization so I don't have to guess about when that's going to happen. Another quick note is that if you're thinking about where this type of code is implemented, if you're working in a back-end service or something like that, maybe not much to worry about. However, if you're writing UI applications and you're writing methods that take in IEnumerables, if the IEnumerable is passed all around in your application and makes it to the user interface level, if you go to materialize that on the UI thread and you are not sure where that IEnumerable comes from, I have seen instances, I wish I hadn't, but I've seen instances where that kind of thing is passed all the way through a data layer, application layer, and makes its way to the UI. And then someone goes, cool, give me all of the items in that collection, or the enumerable. They don't know it's a collection or not. And what happens? Well, it starts executing a query against the database in the UI on the main thread. Guess what the user experience is like for that? Now, the downside with doing something like forcing people to materialize collections is that if they can't guarantee that it hasn't been materialized in other places, we might be doing that a little bit needlessly. When you have an IEnumerable interface that is backed by a materialized collection already, it's not really obvious to us. And unfortunately, a lot of the time we go, well, I don't know, I can't be sure. Let me just call toArray on it, materialize it, I'll have a copy. But that can get kind of expensive. So just something to think about in your sort of application stack and how your methods are working together. For me, a lot of the time, because I am sticking to this iRead-only collection or iRead-only list kind of parameter passing, it's reducing the instances where I am materializing enumerables and making extra copies of things when I don't really need to. But hopefully that provides a little bit more, clarity and thought process around what you should be passing in to a method. So let's go look at the other side of this. Now, if you did go back and watch my previous video on enumerables and iterators and how I think they end up getting misused a lot, I wanted to call out that enumerables, for me, for a long time, were a saving grace. There were so many instances where I was dealing with these return types right here that were something like an iRead-only list or just a list or an array. And what would happen was that the calling code would ask for this collection, and underlying code underneath the implementation would go materialize a ton of data and pull it back up. And it meant that as the caller, you didn't really have a lot of control. If you wanted a little bit, you were forced to just get everything. So IEnumerable was a really nice option to kind of have this streaming API. You could just ask for as much as you need. So for a large majority of my C# career, I've been using IEnumerables as a return type. And when I use them in my own development, if I'm just working on my own projects, I don't run into that many issues, but definitely in bigger projects and in team settings, I see that this kind of thing ends up getting misused. And it's not because I'm better than other people. I just think that it's really common for us to slip up and not realize that we might materialize something multiple times or iterate over data sets multiple times. It's just an easy thing to mess up. So when I think about some of the goals for return types, it's kind of similar to what I think about when I'm passing parameters in. I don't really like to deal with mutable things. And I have a little bit of a code example here on the screen here from line 70 to 73 that talk about a mutable example that I just don't really think sits well with me, and I try to design APIs that avoid this. So I mentioned here that with a mutable list, so if we think about this being just a list coming back, right, so just a list like this, what happens technically, so you can't yield back either, but what could happen is that if we were to say enumerable APIs, that's the name of this class, then we call the method get something, someone could call add to right on that list. And if we weren't returning back a copy of data, so like a new instance of a list that we wanted to pass back up, but instead we were referencing our own list that we had internal to this class, what could happen is that we now have a situation where someone is able to mutate that list on the outside. So for example, if it looked like this effectively gives someone direct access to whatever our list is. And you might have, an interface that has multiple different implementations. Maybe some people are doing a good job of implementing this, and I think you could have situations where people are doing a really good job of returning a copy of the data, but it's really easy for someone to come in and make their own implementation, and in that particular case, they go, well, I have direct access to what I need, let me just pass it back up. If they're not doing something like this and providing a copy, that means that they're effectively getting access to the underlying collection. Something like toArray or toList, and in this particular case, I should have just left it as toList. We can't cast an array to a list. These types of things make a whole copy, and that way the caller, if they were to do something like add 2 to it, that's fine because they're going to have their own copy. But I mentioned in the past I had some challenges with lists being this type of thing that effectively didn't give a lot of control to the caller. It meant that they had to get the whole collection of whatever they were asking for back, and that didn't really sit well with me. But there's two weird things going on here. The streaming API of an IEnumerable is really powerful in that it gives us control, but really dangerous in that people don't know if it's lazy evaluated, if it's eagerly evaluated because they can't see what it's backed by. And as a result, there's a bit of a hybrid approach that I think makes a lot of sense here. And for me, that means going to iRead-only list. iRead-only list in recent times has been my go-to as return types for collections on methods. The first reason, because we were just talking about mutability, is that this thing is immutable. That's really handy for me in preventing that situation that I was just explaining. And then you might be asking, well, okay, well, why don't you just use an iRead-only collection? Isn't that better? Well, if we think about some of the goals that I mentioned earlier, if we have the ability to return something that meets the iRead-only list interface, that means that our caller is able to index into it and get a little bit more information. So technically we're doing them more of a favor on the providing part, so the output of the method, by giving a more specific implementation, if we're able to. If the algorithm and thing that you're designing doesn't really lend itself well to that, because you need to use things like queues and stacks and you don't want to be able to index into them, that's okay. You could use our iRead-only collection, but a lot of the time what I end up doing is I'm creating arrays or lists anyway behind the scenes, and I'm going to return that all back up, but I am masking it with an iRead-only interface. Another reason to use iRead-only list here instead of an iRead-only collection is performance, and we'll see that in a later video in this series. Another really awesome benefit to using an iRead-only list instead of an IEnumerable right here is that it allows us to avoid a pretty dangerous problem that can occur with IEnumerable. So watch right to the end, and after I'll show you how to prevent that with iterators and IEnumerables and why that's dangerous. But one of the main reasons that I have switched to using an iRead-only list as the return type instead of an IEnumerable is because I have moved a ton of my APIs to a paging approach. Now, this doesn't work all of the time because I don't need every API I write to have paging support, but honestly, this has solved every single one of my IEnumerable issues as of late. So let's look at paging next. So with paging, if I look at the API that we're using here, I want to be able to get an iRead-only list back. That's exactly what we were just talking about. But the other thing that we need to be able to do is provide an offset and a limit. And if you're familiar with writing SQL queries, and I feel like that's a little bit of a dying thing because everyone's using stuff like Entity Framework, and that's totally cool, but I feel like a lot of people aren't spending time writing SQL queries, and if I say offset and limit, that might sound kind of weird to them. But in SQL queries, there's a lot of this notion of being able to page the data that you're asking back for from the database. And from working with databases a lot and being able to pull a ton of data back from databases, this is where I got the idea to start structuring a lot of my APIs this way. I mentioned that my approach with paging is a bit of a hybrid. So we get something that's almost like streaming. So we're not getting single items at a time, but we are getting pages that we can ask back for at a time. And that means that when it comes to materialization, we also have some control over that. So it's not as much control as an IEnumerable, where we're getting just one at a time. I mean, you could technically do that by setting the limit of the page to just one every single time, but we're also not forcing a materialization of something that we're not able to handle. So we get the control and we get enough granularity that for me, a lot of the time feels really powerful. So let's walk through a little bit of code that kind of highlights how this paging might work. So let's pretend that we have something that's coming from a database. And here I'm just declaring a single array. So it's really simple, obviously, but this could be something that is a query going to a database and pulling back 100 records, 1,000,000 records, whatever it happens to be. Now, what you should be doing is in your query, if this is truly where it's coming from, you would write your query such that it's taking in these paging parameters. So this is a pretty bad example because I'm showing you an array, but talking about some database concepts as well. But if you can avoid it, you want to be doing all of your paging at the database. You don't want to pull back way more records than you need and try to page them in memory. Just a heads up, because that's not exactly what this code is showing you. I just think that that's really important to understand, because you want to do all of that work elsewhere, not on your machine that's doing all the processing. The databases are really good at handling that for you. Let them do it. And then you only bring back what you need over the network, and you're saving a lot of resources that way. So in this particular code, I have the paging built into this for loop, but how this would look normally is if you had the database doing that paging for you, you'd only have a certain number of records come back. And I just wanted to highlight that you can see I'm creating a new collection here on line 85. And this goes back to what I was talking about a little bit earlier. We are not in a situation where we're just sharing some internal data, right? So we're not using a list that we're just holding as a field inside of the class, and then letting other people manipulate that by returning a mutable collection as the return type. We are always going to be making a new one, and I wanted to mention here as well that depending on how you're using a limit, if you can be confident that that limit is not going to be something that's set really high. So for example, if you set the limit to be the maximum integer value, and then you let your database pull back the maximum integer value of records, that might be a little bit too big. And if you were to do that and then try to declare a list with that initial capacity, you might be a little bit upset. But I have some situations where I enforce that there's a limit of, say, 1,000 items or something that's safe. This is going to be context dependent. And then that way I can always initialize my collection to be the right size that it needs to be. And if I'm able to do that, I often just use an array instead of a list. From there, we're going to populate that collection and then return it. So really simple concepts here, but the three things that I wanted to highlight are that we're going to be doing some type of paging. And if you're dealing with the database or some other external data source, as much as possible, try to force the paging to go beyond that system. The next part is that we have a new collection that we're creating. That's going to be what we're returning back out. And it's a new collection so that we are not altering any internal data in our class. And we are using that return type that is a read-only version of it. So we are giving a reduced scope of what that collection is able to do. And then finally, we're just going to be populating that collection with the records that are coming back. And if you were dealing with stuff in memory, then taking this kind of approach totally could make sense. So I'm trying to explain how this works with databases, but also showing you how it works in memory. So to recap what we talked about, as parameters going into methods, a lot of the time I am using IReadOnly list and IReadOnly collection. IEnumerables are still things that I use, but generally it's less and less frequent. If it's something that's just going to be filtering, and I'm very confident that I'm just doing one iteration over the enumerable, and I'm never going to be materializing, and I never need to do a second pass, then I might opt for an IEnumerable just to be a little bit more lax. As return types, I have gone from using IEnumerable to IReadOnly lists, and that's because a lot of the time I am using a paging implementation. If my API isn't set up well for doing paging, I have to consider whether or not I'm able to just stream the data back or make a copy and make it really obvious that I have an IReadOnly collection to deal with. Now, I do want to start talking about performance of some of this stuff because I think that that's really important, but I mentioned a little bit earlier that I wanted to talk about a dangerous case with iterators that we can experience with enumerables. Moving to a paging approach can avoid this for us, and if you want to see more information about this dangerous case, you can check out this video next when it's ready. Thanks, and I'll see you next time.